Hello everybody, today I would like to tell you a little bit about ATA36, which is bleed, and especially on this CFM 56-5B, which belongs to A320. So let's take a look at it. We can start on the engine. The bleed is taken from two places, from the high pressure stage number 5 and high pressure stage number 9, which is on the other side of the engine. During low speed operation, the blade is taken from the stage 9 because the air pressure from the stage 5 it's not sufficient to supply aircraft systems like air condition, for example, or anti-ice for the engine or for the wings. In that case, the bleed is taken, as I said, from the stage number 9, and it is released to the system through the high pressure bleed valve, and then it continues through the bleed regulating shuttle valve. Let me expand this a bit. The bleed pressure regulating valve also operates pneumatically, and it's controlled electrically by bleed monitoring computer, but opening and closing can be controlled as well by bleed pressure regulating valve control solenoid, which you can find downstream of the bleed air pre-cooler, which is exactly here. Downstream of the PRV we can find overpressure valve, which is here to protect system against damage from the overpressure. And since bleed air is very hot, we need to cool it for the system, and exactly for that we have here fan air valve, which brings cold air from the cold stream of the engine to pre-cooler, from where the hot air flows out of the pylon. Fan air valve as well operates pneumatically, and it's controlled by fan air valve control thermostat, which is installed next to PRV control solenoid. And now you basically know how we control temperature and pressure of the bleed air which is coming out of the engine. But let me continue where I stopped before. When the engine is on the higher operation limits, which means about the idle, the pressure is sufficient, which means that high pressure valve will gonna close, and the pressure from the 5th stage is sufficient to supply the airplane systems. Inside here you have a check valve, which is a small valve with the flaps. Whenever the pressure comes from the high pressure system, this valve is closed, and whenever this high pressure valve is closed, the IP valve can open and supply the pressure to the system. Again, when we get back to the idle and this pressure is not sufficient, the high pressure valve will open again and supply aircraft system. That was basic information about this system on CFM 56-5B, and today I need to replace high pressure valve, so let's take a look at it. And as always, I need to follow all safety precautions. I need to also pull all the CBs, deactivate slots which will prevent damage to the leading edge and the reversers. And when this is done, I can open the left reverser. Then we'll continue with removal. Since all CBs are pulled, I'll start with the sense line and with the connector. Through the sense line, high pressure valve is connected to the bleed pressure regulating valve, and whenever bleed pressure regulating valve is closed, of course the high pressure valve is closed. Yeah, that's sense line. Now connector, as always, connector pliers with the soft jaws. Yep. That way I'm not gonna damage connector. by the knock thread. Let's use a protection for some line. Prevent anything to get in, and connector as well. Yep. Okay, now we can continue with the clamps, and we need to remove 4 clamps, 2 on the duct and 2 on the valve. With the duct ones, that's 1. Second one. Now the one on the valve. You can leave it on the table. No, okay. The other clamp as well.
Thomas, emergency light test you have done or not?
Not yet, no. Well, that's it. Now it should fall apart. So, let's start. Great. So, this valve itself, it's a butterfly type, which means that you have spring-loaded valve inside, which turn like this. Of course, it's spring-loaded to closed position, so every time when it fails, it will close. That's it. We can install the new one. Of course, we have seals in here, which we need to inspect now. But yeah, other than that, we'll just install the new one after inspection, of course. And since valve is out, I can show you how IP valve look like. And as you can see, it's just 2 flap device. That's it. That's all what you need. Okay, since both O-rings are in good condition, we can install them back. That's one. That's the other one. And we can proceed with the installation of the valve itself. The thing is that it have a special notch, so there is only one way how you can install this valve, and it fit exactly here on this position. There is a groove for this part. So we can proceed with installation. Before I can tell you that this valve you can put it on MEL. This valve can be and then you need to perform the activation of this valve, which means that you pull this plug out and you install it on the hole, on the lever of the valve, which means that it will be mechanically blocked from the movement. Yep. But yeah, it was a MEL procedure, and let's put it back. So as you can see, it sits on position now. You cannot turn it to either way, so this is exactly the place where it should be. And we can install 2 clamps around. Torque value for these clamps are written directly on the clamps, so be sure that you know the torque value before you install the clamp better, because otherwise you can have a trouble to find it out later. So let's put it on. second one. Next crucial thing, or very important thing, and hopefully you're not gonna mess it up, there is almost no chance to mess it up, is arrow. This arrow shows you the airflow, which of course is this way air flows into the system. So yep, cross check it with an arrow, and yep, we'll install those two clamps, and yeah, then we proceed with a tightening. So torque volume checked. One, two, okay, and tightening. Now, procedure is first torque with 50% of the nominal volume, and yeah, then we hit it with a hammer to be sure that it sits on the correct position. That's one. Okay, two. Okay, now we need to hit the clamps with a plastic hammer, so it will sit a bit. Then we will torque it with 100% and do this procedure again and torque it one more time. Now we need to torque it with the volume which is required. We'll see how much we will move. Still going. Okay. Second one. Third. Oh, this one sits well. Fourth. Again, we need to hit it one more time. Second torque. As you can see, it sits again a bit. Yep. Good. Let's do it one more time. See, basically almost no movement, which we want to achieve. Perfect. Yep. Now we need to install sense line and yeah, and then connector. installation of the sense line, we need to lubricate. We need to lubricate threads of the union. When that is done, we can install sense line. Okay, since that is in position, we can torque it, of course. Okay, that was union. Now connector. And tied it a bit with the connector pliers. Perfect. You can't really over torque any connector with the pliers, because whenever it's starting to be too tight, it will slip. That's why you have this soft jaws on it. Yeah, but basically installation has been performed. Now I need to apply developer and we need to test it. This is a dry developer. Inside is powder, which we need to apply on the joints. How this developer works, when it gets dry, which soon will be, you will have a white line of the powder, and whenever there will be leak, this on the place where the leak will detect it, you will see a strain or like line. The leak will blow away the powder. And that's how you will find out that there is a leak, because of course during run-up you're not gonna be here, you can't really see what is going on with the component. So this is the only, okay, there is one more possibility how to make a leak check, but I always prefer to use this one. And whenever you again open a C duct, you will see if there is or there is not a leak. It's very simple and easy solution. Yep. But that's it. Now I'll wait until it gets dry. Meanwhile, I will pull I will close all CBs, and yeah, we can later go for engine run-up. But of course, before run-up, my colleague performed duplicate inspection, and now he's helping me with the closing of the reverser. Whenever this is done, we'll push airplane out of the hangar and perform run-up. Good. And since the job is done, we can remove collars, close CBs, and for the slots as well. And we can start with waking up the airplane and to get ready for run-up. And since on the run-up stand we don't have a GPU, we need to start APU as a source of electricity and of course for supplying high pressure air for the startup of the engines. And since my colleagues work on engine number 1, we need to start both engines, and we start with engine number 1. And
16 ignition.
Stable.
Engine number 2.
Start well. pressure open. Perfect.
Fuel flow 0.
As you can see, valve work as it should, so we can switch off the engine and we can perform leak check. And after visual inspection, both me and my colleagues confirmed that there are no leaks, so we can close the reversers, close the fan coils, and we can release aircraft back to service. So, all done. We can go. This is more or less all what I want to tell you about high pressure bleed valve and bleed system on A320. If you have any questions, please write them down in the comments below. As always, I would like to ask you to don't use this video as a replacement for the maintenance manual, but always use latest documentation released by manufacturer. From my side, this is all. My name is Tomáš. This was Aircraft Maintenance with Zeto. Thank you for watching, and I will see you next one. Bye.